Hello out there, welcome to this tutorial. In this video we'll be looking at the sphere, where we'll be treating surface area and volume. So we take the sphere. This is a three-dimensional solid shape with radius r. So the volume of this sphere is 4 over 3 pi r cube, and the curved surface area, it has only one surface and it is just the curved surface area, so we just refer to it as the surface area, which is 4 pi r squared. And we cannot separate sphere and hemisphere, so we also look at the hemisphere. A hemisphere is half of a sphere, so we have it as radius r, so that the volume of these is half of the volume of the sphere, which is 2 over 3 pi r cube. Also, for the curved surface area here, this is the curved surface area. A hemisphere has two faces, the curved surface and the circular face. So the curved surface area is 2 pi r squared, which is still half of the surface area of the sphere, while the circular face is pi r squared. So that when we are looking for the total surface area now, the total surface area of the hemisphere is the area of the curved surface plus the area of the circular face. That will give us a 3 pi r squared. And from here we look at solving two or more problems on the surface area and volumes of either sphere or hemisphere. So we take our first problem. Problem 1. The radius of a solid sphere is 7 centimeters. Calculate the A, volume, B, surface area of the sphere. Take pi equal to 22 over 7. So in the solution to this problem, we are going to have the volume to be V equal to 4 over 3 pi r cube, and substituting in the value of pi and r. Here our radius is 7 centimeters. Pi is to be taken as 22 over 7. So we have the volume to be 4 over 3 times 22 over 7 times 7 cube. So if we press our calculator, we are going to have it as 1437.3333. But to one decimal place, we have it as 1437.3 cubic centimeters, which represents the volume of the solid sphere of radius 7 centimeters. Then we go to the B part of the problem. The surface area is 4 pi r squared, and substituting in the pi to be 22 over 7 and radius to be 7. So we have 4 times 22 over 7 times 7 squared. 1 7 here, we go with this, so we have a 7 here, 1. So one of the 7s is taken away with this. So we now have 7 times 22 times 4, which gives 616 squared centimeters, which represents the surface area of the sphere, whose radius is 7 centimeters. So we go to problem 2. For problem 2, calculate the volume and mass in kilogram of a metallic spherical object of diameter 28 centimeters if the density of the metal is 1.6 grams per cubic centimeters. Take pi equal to 22 over 7 and correct answers to 3 significant figures. So in the solution, we have to calculate the volume first. From the volume, we already know that mass is volume times density. So we go So volume is 4 over 3 pi r cube. Our pi is 22 over 7. Our radius is going to be half of the diameter, which is 28 divided by 2, which will give us 14. So substituting in these values, we have 4 over 3 times 22 over 7 times 14 cube. So pressing the calculator here, we have our volume to be 11,498.66666. So to 2 decimal places here, we have 11,498.67 cubic centimeters. And to 3 significant figures, we are interested in the first one, the second one, and the 4. But then we check the next value, which is greater than 5. So we make it 1 and add it to 4. So it becomes 11,500 cubic centimeters. So we now go to calculate the mass of the spherical object. And we say mass is volume times density. So we've calculated the volume. And we are going to use this volume, not the rounded value. So we use the raw value. That's going to give us 11,498.67 times the density, which is times 1.6. And multiplying this out, we have 18,397.9 grams. And we are meant to give our answer in kilograms. So that will give us 18.3979. We have divided by 1,000, since 1,000 grams make 1 kilogram. So converting these to 3 significant figures, we have 18.3. We check the next number. Since it is 9, we make it 1, add it to 3. It becomes 18.4 kilograms. And that is the end of solution to problem 2. We go to problem 3. Problem 3. A hemispherical solid material has radius 4.2 centimeters. Calculate the A, volume, B, surface area of the hemisphere. We take pi to be 3.142. And starting from A part of the problem, we know the volume is 2 over 3 pi r cube. And our radius here is 4.2. Our pi is 3.142. Substituting this into the formula, we have 2 over 3 times 3.142 times 4.2 cube. So if you press your calculator, we have it as 155.19 cubic centimeters. And that's the volume of the hemisphere. Now we go for the surface area of the hemisphere. We know from the beginning the surface area is 3 pi r squared. Still substituting r equal to 4.2 and pi to be 3.142. That surface area will be 3 times 3.142 times 4.2 squared. Simplifying this from our calculator, we have the result to problem 3b to be 166.27 squared centimeters. And that's the end of solution to problem 3. We go to problem 4. For problem 4, a solid sphere has a volume of 38,808 cubic centimeters. Calculate its radius and hence its surface area. Take pi equal to 22 over 7. In our solution, we need the volume of a sphere, and we are given the volume here. We are looking for the radius, so we are also given the value of pi. So what we do now is to substitute v and pi to enable us calculate the value of r. So we have it as 38,808 is equal to 4 over 3 times 22 over 7 times r cubed. We make r cubed the subject of the relation. This is going to be 38,808 multiplied by 3 times 721. We multiply by 21, then divide by 4 times 22. So pressing this from our calculator, r cubed is 9,261. To get r, we find the cube root of 9,261. That gives 21 centimeters. So we're done with the first part of the problem. We go to the second part, surface area of the sphere. That's 4 times 22 over 7 times 21 squared. So we have the result as 5,544 squared centimeters. And that's the end of solution to problem 4. We go to problem 5. A metal sphere of diameter 16 centimeters is melted and cast into smaller balls of diameter 4 centimeters. How many smaller balls can be recast? This is an example of change of shape. We have an original shape, then we're changing it to another shape, though they are of the same shape. It's still referred to as change of shape. Now, what we do is to get the number of these smaller balls from the bigger one, we find the volume of the bigger one, then divide it by the volume of the smaller one. So let's go. So the solution is number of smaller balls. Now we've said volume of the big ball divided by volume of the smaller ball. So we know the volume of a sphere to be 4 over 3 pi r cubed. We're taking the radius of the bigger sphere to be capital R and that of the smaller sphere to be small r. And if you look at it, 4 over 3 pi will go with 4 over 3 pi. So they are gone. We are now left with r cubed over r cubed. And our big R, the radius of the bigger ball, that's a metal sphere of diameter 16 centimeters. The diameter is 16 centimeters. That will give us 8. And the diameter of the smaller one is 4 centimeters. So the radius will be 2 cube. So if you look at this, 2 cube is 8. It removes one of the 8s here. We'll be left with 8 squared. And that gives us 64 balls. So that's the end of solution to problem 5. And this is the highest we can go in this tutorial. I hope you enjoyed it. Please check the description section of this video on our YouTube channel to get links to other videos on solid shapes with respect to volume and surface area. Until I come your way again, goodbye.